Hi everyone, let's discuss about summing, scaling and averaging amplifier using op-amp. In this summing, scaling, averaging amplifier, we can do two types. One is we can use inverter circuit for doing these configuration, or we can use one more stuff, non-inverter. So first we move on the inverter circuit, how we can do this summing, scaling and averaging amplifier. For all these three, the basic stuff is same. After that we can change it according to the which particular portion we require. First we will go with the inverting operation. So inverting amplifier, if you are taking, you know that what is the stuff we are going with. So in this case we will take like positive here. So in this case usually last we are discussed like positive we are connected directly ground and negative we are giving some resistor and after that RF, and you can use RL like that. So here we are adding some extra stuff also. Listen it. So usually what we are doing negative, we are giving something like here one R1, okay, then here one more card as a RF, or you can use here also R1, anywhere you can use it, okay, yeah. And this is you are given to the output V0, okay. This is how actually look like your inverting amplifier. Here what are the changes you have to do? You can use one more portion card as a RL if you want. So this portion is nothing but V0, okay. This is not a compulsory, you can use it anyway. For design part we are not using anywhere this RL. Here our aim is to make summing, scaling or averaging. That means summing part or scaling or averaging we require more than one input, so we cannot use one like. So we can take like, instead of R1 I will take one more R2 and one more R3. So in this we are taking as a like this. So here instead of giving one voltage we are giving three different like V1, V2, V3, okay. So this is the difference between summing and only single inverter amp. So summing, here we are taken example for 3 input. You can take 2 input also, 4 input also, anything you can take it. So each input having some resistance and that connected to the negative terminal, then R. So for positive you can directly connect to ground possible, or you can use one resistor. This is actually not compulsory. I am calling this resistor as a RP. So what is this RP means? The parallel to the whatever resistance there in this excluding RL. So here resistance like R1, sorry, this one make R2, R1, R2, R3 and RF. So RP become what? It is nothing but R1 parallel to R2, parallel to R3 and parallel to RF, okay. So whatever resistance present in the input side and feedback side, all the resistance parallel we are taking over here and making ground. This is not a compulsory resistance, you can use it or you can ignore it just for the making the grounding portion as a proper part. We are using such a part, that one resistance which make all the portion, that means offset voltage whatever present, we can make it zero using this stuff, okay. So I hope you are following with this. Now our aim is to get the equation. So how to get the equation for inverting amplifier? You people know about the step what we are done, how we are done V0 by Vi. The same procedure here we have to use, but instead of that we have to use like V1, V2, V3 together. Here we can take like this portion is 1, we can call it as a I1. Similar way second one is I2 and last one we can call it as a I3, 3 current. And anyway this current is nothing but IF. So previously you remember that how we are done inverting amplifier, nothing but we are taken I1 is equal to IF, yes or no. So instead of that here we have 3 current coming, so we can take something like this I1, okay, using KCL. I1 plus I2 plus I3 is equal to IF. Okay, previously inverting amplifier we have taken II or input I is equal to IF, yes or no. Instead of that we are taking here, because II is 3. So we have to take 3 current, I1, I2, I. So what happens? What is I1 actually? If you see here I1, so this portion is I1. Here the present is, voltage is present, V1, and R1 is present. Anyway, one more part we have, this is portion, we can call this portion is VF. So the feedback is connected to this side, so we can call that VF. So what happens to the I1? If you take I1, it is 1 voltage V1, 1 voltage VF, and resistor R1. So we can call as a V1 minus VF divided by R1. Similar way, plus for I2 we have V2 minus VF divided by R2, because resistance is R2 over. Similar way, so V3 minus VF divided by R3. And what about VF? Sorry, IF. IF is nothing but V0 and VF is there in between, and RF. So how to find current? Very simple. If you are taking something like this, this is one voltage V1, this is voltage V2, this is resistance, and here current. So current is nothing but the difference of voltage divided by resistance. This already we discussed. Same theory here. So it is in between V0, VF. So V0 minus VF divided by RF. Okay, I hope you are following this. Now simplify this one, because everywhere we have VF is there, and we have V1, V2, V3, R1 like that. So you can simplify this one. Now from the virtual ground concept, we know that VF is connected to the same portion of this portion where the positive is connected. Okay, you can take VF the value of previously taken like that, but what happens, it will give you the exact value, but here we won't require exact value, we are going with the ideal value. So we treat that whatever the value present in the V positive, V plus is equal to VF using virtual ground concept. Okay, so virtual ground concept already I explained, so just check it out. That from that we can say that VF is equal to V plus. Here the positive terminal is connected ground, so we can say VF is equal to 0. So our term made easy, everything we have 0, so only one terminal we have, so we can easily write this one. So like that, V1 by R1 plus V2 by R2 plus V3 by R3 is equal to, we have actually in this case the V0 minus VF we are taken. If you are taking to the V1 minus VF, so from this end to here, and V0 you are taking from this side, so usually we can take VF minus V0. Or one thing you can remember, if you are using inverting, better to take it as a one negative side. Either you can take input to negative side or output negative side, left to you. So I will take in the output side, so it is minus V0 by RF. Okay, this negative indicates you are giving either inverting as a negative or you are taking as a output as a negative portion. So simplify this one, you will get as a, actually my aim is to get AF. So how to get AF now? AF is nothing but V0 by V in. So go with the that here. So the final formula we can say that first we'll check out what is V0. Okay, V0 is equal to if I take like this, RF go to here, you can take minus RF. Okay, because V0 divided by RF, RF come to this multiplication for our part, and V1 divided by R1 plus V2 divided by R2 plus V3 divided by R. Okay, this is the major formula, I can call A or 1 whatever to these three amplifiers: summing, scaling, averaging. Up to here you have to do same. Now for each portion you have to do different step. First we will take summing. Summing meaning is actually what? It is addition. Addition means if I take one answer V0, then I have to get something like V1 plus V2 plus V3. This is called addition, summing. Yes or no? So in this we are calling about inverting amplifier. So minus of all these stuff here. Okay. So to get this type of answer, what you have to do? RF and R1 we have to take as a equal portion. So remember that if you are dealing with this summing, so you have consider as a all the resistance value equal. So then it is called as a summing amplifier. So all the resistance equal means what happens? It is nothing but R1 is equal to R2 is equal to R3 is equal to RF. So if all is equal to R, what happens? You can take as R. If you simplify, V0 is equal to RF is nothing but minus R divided by all R means I can take divided by of R. Okay, so V1 plus V2 plus V3. So here both are R, you can cancel out. So this is the your final answer. This is what summing called. Okay, summing means I require the addition, that's it. So what you have to do for summing? From this equation we have to consider all the resistance equal. Now second one we are calling as a scaling. It is also called as a weightage. Okay, what is this scaling, or we can call as a weighted amplifier means it has certain weightage for each input. So whatever we are getting from this portion, that we can call as a nothing but it is a scaling or weightage. So in this case we are not making equal of R1 is not equal to R2, not equal to R3, not equal to RF, not equal to R, and it is nothing but whatever equation A is there, that. So we can write something like V0 is equal to minus RF by R1 V1, okay, plus minus RF by R2 V2 plus minus RF by R3 V3. Listen carefully here. I made for equation A, okay, everywhere I am taking equation A only, from that I have doing, okay. So here what I changed then, simply multiplied RF every time. So whatever this term is there, this is called scaling, okay. So this much weightage I can give to the V1, V2, V3. So depending upon that one we will get. So summing means we have to make all resistor equal, scaling means we have to make not equal, simple. So third one we have to make average. So average circuit we can take as a again equation here. Our aim is what? Average means how many input is there, that much you have to multiply. So what we can do R1 and R2 and R3 is equal to 3 we can do. What is this magical term 3 will come? The 3 because our aim is to make as a the term RF divided by all these addition, what we can call R1 plus R2, R3, whatever. So we can take all these resistor equal to some, we can call as R. So what happens usually, so R is equal to, we can take as a 3 something. So what happens usually, if you take all the R, so it become minus RF divided by R. Yes or no? Because R1, R2, R3, all these things are equal. So this R term if you take 3 and RF you are taken as a 1, okay. So what happens? It becomes 1 divided by 3. So why I am taking R is equal to 3, 1, this in magical term you look like, but our aim is to make average. Average means whatever input we are getting, that divided by total part. So everyone know the average formula, the total input divided by total number of that. So for that reason we are doing this stuff. So always remember, you have to take how much input is there, that much as a R value. RF is always 1. So if you do this one, what happens? Your answer is getting V0 is equal to minus 1 divided by 3 of V1 plus V2 plus V3. Okay. So everywhere you have to write negative. It is very important, so that is a inverting amplifier you are showing. This is all about how we can do summing, scaling, averaging amplifier using inverting amplifier. Next, discuss on summing, scaling and averaging amplifier same using non-inverting terminal. So the thing changes is input we are given instead of negative to the positive. So first write as it is what we have the structure. So any closed circuit if you are taking, you can take like one RL, this is optional, and ground it. This portion is we called V0, and from this V0 we have one RF resistor, okay, and we have one R1 resistor and connected to negative, okay. This is the common structure. So in our case we are using as a non-inverting. So non-inverting means inverting terminal is connected to ground. Usually we have to use as a one resistor here and connected to the positive terminal, but here we are doing summing, scaling, so more than one we can use it. We can use 2, 3 like that. Here inverting we use 3, here we can use 2, okay. For just for your understanding purpose, you can use 3, 4 like that also, okay. So now here this portion we called R1 and this portion is R2 and V1 V2. Okay, so whatever the term here, this we can call as a VF. Why? Because the same term consist here is our feedback VF. So virtual ground concept, this and this should be equal, so I am calling that one VF. You can call as a V2, VA or V3, any name you can give it, doesn't matter. Also you can take this optional. Okay, you can take one more resistance like RP and ground it. Okay, RP resistance, we know that it is parallel to the all the resistance present in the circuit. So R1, R2, here the R1 become it become same name, so change it. Okay, you can change RA, RB also. So I will change this name to R3. Okay, anyway, you can take according to this. So R1, R2, R3. You can take this one RI like that also. Okay, yeah. Now we can go with the similar method what we have done here. First apply KCL. The thing changes here. KCL same here. V1, V2. We have two current. One is I1 and here one current is I2. Okay, so it is nothing but I1 plus I2. The thing is, in the inverting amplifier we are taken is equal to IF because it is connected to the feedback and we have IF current. But when you are connecting positive, that is not connecting to the output side, so we don't have any current like output side, so it should be 0. That is the major changes between inverting amplifier and output non-inverting amplifier. So we can take I1 plus I2 is equal to 0. So apply the I1 formula, same what we have done previous. V1 minus VF divided by R1 plus V2 minus VF divided by R2 is equal to 0. So from this our aim is to make as a VF is common. You can take VF outside and make it V1. How to we can make? You people may remember that if I take V1 minus VF divided by R1, I can write something like V1 by R1 minus VF by R1. Okay, so this is the common terminology. That means I can isolate V1 VF. The aim is I want to make only VF one side. Okay, so what happens if I simplify this one? So we can write something like V1 by R1, okay, plus V2 by R2, okay, is equal to, I will take VF this side, minus is there, so this become plus VF. So we have two things, 1 by R1 and 1 by R2. So I will directly take 1 by R1 plus 1 by R. Okay, so now our aim is to find VF. Before that we can multiply this and simplify it. So we know that we can multiply this to here and this to here, this here, like that. So if you simplify that one, we will getting as a R2 into V1 plus R1 into V2 divided by R1 into R2 is equal to, here what we will get in the this side we can have 1 by R1, 1 by R2, so we can take VF is equal to, so just multiply this one to here, so you will get as a R1 into R2 divided by R1 plus R. So I simplified directly this step. I hope you people are able to do it yourself. I actually skipped one step directly, so you will get this answer. You know that 1 by R1 plus 1 by R2 is a parallel, we know that this answer. Okay, here VF into, so this will come to the 1 by of that, so we will get opposite of that parallel, so is equal to VF. Now your aim is to simplify, so this and this cancel, so you are getting as a, this is the answer. So this is nothing but your VF. So what is VF actually? We know that according to the formula, AF whatever we are taken, that is nothing but V0 and VF actually we are taking as an input here. Yes or no? Whatever name you can give it, V in also. Okay, this is nothing but the gain portion. So we usually call V0 is equal to A into whatever. Here we are taking VF, so A into VF. So from this portion, if you know the VF, so VF is equal to, we can take V0 by A also. Okay, so what is the gain of the non-inverting? We know that gain of the non-inverting AF is equal to, already we got from the previous, 1 plus RF divided by R1. Okay, here R1 place we have taken RK. R1 means whichever connected to the inverting, so here we can take R. Okay, Yeah, this is the what we have feedback. So that we can apply here. From that we have to find as a V0 value. So what is V0 means? A into Vf. So Vf we got, A is this one, apply. So V0 is equal to AF means 1 plus Rf divided by R3, okay, into Vf. Vf is nothing but R2 V1 plus R1 V2 divided by R1 R. Okay, this is the main formula what we got for the summing, scaling and averaging amplifier. So I will call same equation A. First we will take as a summing amplifier. So what changes I have to do to get summing amplifier? If you look at the circuit, my aim is to make V1 plus V2, that's it, and all the other stuff becomes as a 1. Okay, so how to make this one? If I make this portion R1 R2 is a equal, what happens? R1 R2 is a equal means I will get as a something like all become 1. Okay, so it will portion, and here RF and R3 also we have to take as a equal. So what happens usually? How we are done previously, do same method. R1 is equal to R2 is equal to RF is equal to R3 is equal to R. So apply to the equation A. So what happens? We have 1 plus RF and R3 is same. Okay, RR. So you will get R divided by R means 1. Okay, 1 plus 1. We can call this one as a 2. Okay, and then here we can take R into V1 plus R into V2 divided by R1 into R2 is nothing but we can talk as a R square. Sorry guys, one mistake I have done here. Listen carefully. R1 R2 get cancelled, so I am getting R1 plus R2. Okay, so please correct it. The equation A once again, this R1 plus R2, not R1 into R2. So what happens? This is again R1 plus R2 becomes become as a 2R. Okay, so simplify this one. So R is common here, so I can take R2. So this is 2, 1 plus 1 is 2 into R. I will get V1 plus V2 divided by 2R. Okay, so 2 get cancelled, RR get cancelled. So this is the answer. So summing amplifier we are getting as the same theory what we are done in inverting, making all the resistance are equal. Okay, so go for the next scaling. Scaling is nothing but that whatever equation we have, keep it as it is. That is actually the best scaling methodology. Previous also we are done, nothing we are changed. So we can say that R1 not equal to R2, not equal to RF, not equal to R3. So as usual equation, so you are getting as a V0 is equal to 1 plus RF by R3, okay, into R2 V1 plus R1 V2. Okay, you can isolate it both if you want. So you can take, this is R1, make it plus. Okay guys, here R1 plus R2 and this is divided by R1 plus R. So the thing is, this portion we are calling as a scaling part here also. Okay, these are scaling part. So scaling is nothing but not equal, and it is actually equal to A equation and this one nothing different. I simply isolated that. You can directly write same equation also. Next, go for the third. Our aim is to make average circuit. So average circuit means here I am using 2 input. So my final answer actually I have to get V0 is nothing but 1 by 2 of the V1 plus V2. So what can I do for this one to make like this? That I have to do. So here what we can do, we can take like R1 is equal to R2 we can take. So nothing but we have to take as a R. So R1 is equal to R2 is equal to R. Here we have 2 terminal, so take 2. Previously inverter we have taken 3. Why? Because we have 3 input. Okay, don't confuse with that. Here 2 inputs, so it is 2. And you can take as a RF and R3 value is a 1. Okay, that is not an issue. So that is how we are taken previously. So RF is equal to 1 we are taken previously. Same stuff you can take. Okay. So now if you doing with these portions, what you are getting actually applying to the equation A only, you can take like that R3 and RF as it is. You can keep it. You can keep it as a 1 or something, or you can keep it as a different also holds good. So what happens usually, I will make such a way that 1 plus RF by R3 I will keep as it is, didn't change anything, and R1 R2 I will make it equal, okay, according to this case. So here I will get R into V1 plus V2 divided by 2R, okay. So this R and this R cancel, so I am getting as a V1 divided by V2 by 2, okay. This is actually called as a averaging, okay. So averaging done. This portion is amplifier, okay, gain factor. So you can use this one, not an issue, or you can make it this one as a portion, but you have to do such a way that don't do RF is equal to R3. If you do RF is equal to R3, it is entirely wrong. Again, it will become as a summing amplifier. So you can do as a different portions averaging. So you have to make it cancel out. So like that you can take, that is, you can make it as a the portion is something like 0, you can do it, okay, or you can let it be like this one, average, okay. So whatever is the average amplifier, okay. So average amplifier means this is the average operation going on, and this portion is amplifier, let it be, okay. Don't worry much on, okay. So this is all about the summing amplifier, scaling and averaging amplifier using non-inverting.